Hello everyone, my name is TL and today I'm going to be covering the additional topics unit on the SAT Math section. This is going to be one of my last videos on SAT Math for a while, and this is going to wrap up the series that I've done over the coming weeks or the previous weeks on SAT Math, where I provided some practice problems and went over the unit as a whole. However, I'm going to do something a little bit different today. I usually start in Word, but today I'm just going to have some diagrams, as you can see, and give you some questions along the way. Hopefully this will be helpful so that you can see my thought process behind all of these questions. And I'll also leave timestamps in the description below because I feel like that this video might be a little bit longer than the previous ones that I've made. So yeah, before we begin, I would like to introduce Carrot Tutoring. We are a student-run organization that offers free tutoring for those that are eligible. If you want to learn more, feel free to check out the link in the description below and sign up using the form. So the first thing that I want to go over is using the Pythagorean theorem. So I'm going to say that E is parallel to Z. So in this case, these are parallel lines. I could just draw the arrows right here. So E is going to be parallel to Z, and what we're trying to do is find SB. So the first thing we're going to do, we realize that ST is this bigger triangle, and we already have two sides of it. So let's use the Pythagoras equation. And let's solve for that C. So in this case, this is going to be the C side, B side, and A side. The A and B order doesn't really matter. You just have to get C as the hypotenuse. So let's just plug those values in. 6 squared plus 8 squared is equal to C squared. And we get 36 plus 64 is equal to C squared. C squared is equal to 100. C is equal to 10. So that's going to be C. Alright, so now let's move on to the second triangle. So the second triangle, we see that this vertical, or this altitude as we call it, this altitude for the top triangle is going to be 6 and the bottom triangle is going to be 2. So if you can see the pattern, it's going to be 6 over 2 is equal to 3. And that tells us that the top triangle is going to be 3 times bigger on all sides of the small triangle. So in this case, what we could do is divide 8 by 3, 8 over 3, and that's going to be the other side. And then we can use the Pythagoras theorem again in order to find the hypotenuse. So this is going to be a squared plus b squared is equal to c squared again. But in this case, we're using the smaller triangle. So 2 squared plus 8 over 3 squared is equal to c squared. And then that's going to be 4 plus 64 over 9. And let me just convert that. 36 over 9 plus 64 over 9 is equal to 100 over 9. And then we take the square root of 100 over 9, 10, and 3. So the second C is going to be equal to 10 over 3. Now, realize that we didn't solve for SB yet. SB is going to be the combination of ST, which is the hypotenuse of the first triangle, or the triangle on top, and TB is going to be the hypotenuse of the triangle on the bottom. So in this case, in order to find SB, what we need to do is just add those two hypotenuse values together, and we get the length of SB. So let's do that right now. 10 over 1 plus 10 over 3 is equal to, we could just convert this to 30 over 3 plus 10 over 3 is equal to 40 over 3. And that's going to be our final answer. You can also put this into a calculator and get a decimal value, but sometimes it's just best to leave it as a fraction if it's going to be not a round number. Like if this was equal to 5, then I would put it into decimal form. However, since it's kind of an ugly fraction, I would just leave it like that. Alright, so let's move on to the next problem. Alright, so here is the second problem, and we are dealing with a circle, and we're trying to find the area of this shaded side right here. So it looks like it's going to be a triangle, and then we just subtract the area of this circle. So let's do that right now. So the information that they gave us is d is equal to 18. So if you don't know, d is going to be equal to the diameter. So r is equal to 9, since the diameter will be 2 times the radius. Next, we know that it's tangent TE, so it's going to be a right angle right here. Next, TE is equal to AR, so if we were to label this diagram, EA would be 9 and TE would be 9. This is because they are radii, and that is because they extend from the center of the circle all the way to the end of the circle. So now TE is equal to AR, so AR is right here. Let's label that. So we have 18 for AR, and TE is equal to 9. So from this, we can conclude that it's going to be a special triangle. If you look in your reference sheet, it's going to be a 30, 60, 90 triangle. Now we already have this right angle right here. So this is going to be the 60 side, and this is going to be the 30 side. And that's just because sides that are opposite smaller angles are going to have smaller values. So in this case, this TR is obviously going to be greater than 9. So in this case, the 60 would be opposite of that side. So opposite in terms of they are facing each other. Alright, so now that we established it's going to be a 30, 60, 90 triangle, what we could do is use the reference sheet and find the other side. So if you look in your reference sheet, it's going to be 9 rad 3 as the other side. And then let's find the area of the triangle using 1/2 base times height. So let's use 1/2. Base is 9. It's going to be TE, the smaller side. And the height's going to be that side that we found, TR. 9 rad 3. So there's going to be 81 over 2 rad 3. So now that we found the area of the triangle, what we need to do is find the area of the circle. The area of a circle is going to be equal to pi r squared. However, we have to also keep in mind that we're not taking the entire circle, we're just taking the small portion. So let's find the area of the circle first. So that's going to be pi times 81, which is 9 squared. So 81 pi is the area of the circle, the entire circle. Now let's divide that by 6, just because we know that a circle rotates 360. And this is going to be 60 degrees only. So we just divide it by 6. And we get 81 over 6 pi. But lastly, what we do is subtract the area of the triangle with the area of the circle, because that's what we're trying to find. We're trying to find the shaded area. So in this case, what we would do is just put those two together. 81 over 2. Let's put this radical up there. Minus 81 over 6 pi. Now, I know this is not going to look the best. You could probably simplify it a little bit more. Let's say if I multiplied everything by 6, it would be easier. However, I'm just going to leave it as this because I feel like it's already complex the way it is. So this is going to be the final answer. Alright, here I got rocks. So rocks. And what I'm trying to establish here is the idea of inscribed angles. So I did a video on geometry a couple weeks ago, but basically, I did a video on geometry a couple weeks ago. If you want more practice or want a general grasp of the ideas in this unit, feel free to just watch that video and come back. But right now, I'm just going to go over the idea of inscribed angles. So if I were to ask you for the angle of ORS and the angle of OCS, what would you say their values are in relation to each other? So take a second to look at the angles. Alright, so the relationship between these angles is going to be ORS is equal to OCS. And that's because they are inscribed and connected to the same points. So in this case, we have arc OS, which represents the circle's path from O to S. And we see that OCS right here, it goes to this path, OS. So that's one thing we need to keep in mind. And if we look at ORS, it also goes over the same path. So the edges of the inscribed angle are going to be connected to the same points. As a result, the inscribed angle is going to have the same value. So in this case, so in conclusion, the inscribed angles are going to be equal to each other. So one thing to note, K, the angle measure of K is equal to the value of OS, the arc, just because that's the central angle, and assume that K is center. It has to be center. And if it's center, what we call it is a central angle. All right, so that's it for this part, and let's move on to the next one. So here I have this cool container, and it says KT Kool-Aid on it. So what I want you to do is try to find the volume of this, but the one thing I need to do is remove this part, this outer lip of the container. So first, let's recall the volume of a cylinder. So volume of a cylinder is equal to pi r squared h. So if you think about it, this part is going to be the area of a circle, and this part is just going to give the circle some height. Alright, so let's begin. The first thing I need to do is establish the radius. The top part gives us 8 as what? It's going to give us 8 as the diameter. So 8 is equal to d, r is equal to 4. D is equal to 2r. And then once you solve it for r is equal to d over 2. Alright, so let's go a little bit further. Alright, so after we found a radius, what we need to do is find the radius of the inner edge. Remember that the diameter extended all the way out to the edge of the can, the outer edge. But what we want to do is find the radius of the inner edge from the center. So in this case, that's why I have shaded. So what we need to do is subtract this 1/4. So 4 minus 1/4. That turns into 16 over 4 minus 1/4. That's equal to 15 over 4. It's equal to the radius. So now let's plug that in. 15 over 4 squared times pi times h. And that's going to be 15, this value right here. So let's do that. 15 pi times 225 over 16. And that's going to be 3,375 over 16 pi. And you can just leave like that. It's not going to come out as a nice whole number. So this is going to be the final answer. All right, let's keep going. So the next thing I'm going to talk about is interior angles. If you think about a circle, that has 360, because if you go all the way around, that's just going to be 360 degrees. Well, that same thing applies to every single polygon. If you go to every square, right, that has a 90-degree angle, 90-degree angle, 90-degree angle, and a 90-degree angle. So 4 90-degree angles right there. And they all add up to 360. All right, so just realize that for all polygons, the interior is going to add up to 360. The exception to this is obviously going to be a triangle, where the sides add up to 180. 60, 60, 60. All right. So realize that this is going to be a 360 turn, and this polygon has 15 sides to it. So the first thing what we want to do in order to find x is divide 360 degrees by 15. And then we get 4 to 24. And then we get 24 degrees for x. Alright, so in order to find y, assume that this side and this side is going to be congruent to each other. So what we have here is going to be an isosceles triangle. So we have 2y plus x is equal to 180. And if you don't know where I got that second y from, I got it from here. Since it's going to be isosceles, this side is going to be equal to this side, and the angles are going to be same as a result. So we get 2y plus 24 is equal to 180. And then let's subtract that 24. 156 is equal to 2y. And then we have 78 degrees is equal to y. So that's the final answer. All right. All right, so now I'm going to introduce the topic of trig functions. So some of you might have seen this before, SOHCAHTOA. SOHCAHTOA. And this is a helpful way to remember all the trig functions. Well, there are actually 3 more right here. But you'll learn those later on in your high school math career. But for now, the SAT math only focuses on 3 of them: sine, cosine, and tangent. And how you calculate these is going to be dependent on which angle you choose. So it's going to be opposite, hypotenuse, adjacent, hypotenuse, and lastly, opposite, adjacent. All right. So let's take angle C as an example. So this is going to be angle C. If we take sine of angle C, we get the side that's opposite of C, so AB, over AC, which is the hypotenuse. So if you don't know how to identify the sides of a triangle already, the sides that are opposite the greatest angles are going to be the greatest. So in this case, we have a 90-degree angle, because if we were to assume that BC and AB were equal, then these would just be 45 degrees. And this would also be another 45 degrees. As a result, this is going to be the 90-degree angle that we're looking for, because remember, triangles form interior angles of 180, the summation. So in this case, 90 is going to be the biggest angle. And as a result, the side that's opposite to it, AC, is equal to hypotenuse. And the opposite side, as I said before, it really depends on which angle that you're looking at. If you're looking at angle C, this is going to be the opposite side. Let me just erase. So if you're looking at angle C, this is going to be the opposite side. However, if you're looking at angle A, this is going to be the opposite side. In this case, it just happens to work out that these two sides are equal, but most of the time you won't happen to see the equal sides. Alright, so that's pretty much basic trig. And now let's move on to something else. Here I have big and I have small. So big and small. So the first thing I want you to find is the cosine of angle G. And this is going to be angle G. First, set up that fraction. So SOHCAHTOA. Cosine is going to be adjacent over hypotenuse. Alright. So let's look for the hypotenuse. The hypotenuse is obviously going to be the side opposite of the greatest angle. So since we have a 90-degree angle right here, this is going to be the greatest side, BG. BG is equal to hypotenuse. And now let's go to the adjacent. So it's going to be IG in this case. IG is equal to adjacent. And if you're wondering why BG cannot be the adjacent side, it's because it's also the hypotenuse. So in this case, we just say it's hypotenuse instead of the adjacent side, even though it's on the other side of the angle. Alright, so let's plug these in. So cosine angle G is equal to IG over BG. and remember to put those lines over there to represent segments. So far, I don't have any values for BG and IG, but if they had values, you would just plug in the values instead of writing the names down. Alright, so let's try something else here. So let's say that triangle BIG is similar to triangle SML. So now what we're trying to do is establish trig relations. So if I say that sine of G, of the angle G, what is that going to be equal to in terms of the small triangle? Well, we just look at the angle and where it's at, and we find that the angle L is going to be equivalent to the angle G, since they're similar triangles. So sine angle L is equal to the sine of angle G. And if you think about it, sine is going to be the fraction of the opposite side and the hypotenuse side. So as long as they're similar triangles, their proportions would be the same. So let's say that this one was 10 and this one was 2 and this is 5 and this is 1. So this obviously is going to be smaller. The small triangle is going to be decreased by a factor of 2 on all sides. So if we just take the sine of each corner, G and L, we see that 10 over 2 is equal to 5 over 1. So similar triangles, their trig functions, assuming that you're taking the same corner, is going to be equal to each other. Alright. So then there's also one rule that is pretty useful. Sine of x is equal to cosine 90 minus x. And let's try to think about some numbers that we could put in here. X is equal to 40. So sine of 40 equal to the cosine of 50. And remember to put your degree symbols. And let's use a small triangle to demonstrate our point. So if we have this triangle right here, and we say that this angle is going to be 40 degrees, and this angle is going to be 50 degrees. If we take the sine of this angle, that's going to be op over height. And opposite side is going to be SM. And the hypotenuse is going to be the side, SL. And let's go to the cosine of 50. The adjacent side is going to be this side, SM, and the hypotenuse is going to be that side. And I got the hypotenuse again from looking at the greatest angle. In this case, we have a 90-degree angle right here, and looking at the opposite side. So that's going to be the hypotenuse. And there we go. That is a simple proof to that theory, but it will be pretty useful as you go on to SAT Math and other high school classes. All right. So right now I'm going to be covering the equation of a circle. So remember that the standard form of the equation of a circle is x minus a squared plus y minus b squared is equal to r squared. And you might have seen this form before. So in this case, the only thing that's different is b and k and a and h. Just a and b values. The a and b values are going to represent the center. And the same thing with h and k values. Alright, so notice how we have a subtraction sign. So in this case, in order to move to the right, usually that's the positive direction. However, in the equation, it will be an x minus 1. So this is going to be a shift to the right, 1 unit. And x plus 1 is going to be a shift to the left, 1 unit. And then let's do the same thing for y. Y minus 1 is going to be shift up, 1 unit. And y plus 1 is going to be shift down 1 unit. Alright. And also remember this r squared. A lot of people, when they solve for the radius, they forget to square root it in order to actually get the value of the radius. So be careful of that. When it's not in standard form, what you need to do is perform complete the square method. So in this case, what we have is x squared plus 8x plus y squared minus 6y. And that's all equal to 24. Alright, so the first step of completing the square is to make sure that you have all your numbers on one side. So that's pretty much your constants, and in this case, we have all our constants already on one side. Next, what we need to do is take this step by step. So we have two variables here, x and y. So let's take the x squared plus 8x. I'm just going to rewrite this. And what we do from here is we just take half of this, the b value as we call it, because in a quadratic we have ax squared plus bx. So it's going to be the coefficient of x to the first. So then we just have that, 8 over 2 is equal to 4, and we square that is equal to 16. So we have x squared plus 8x plus 16. And we also need to subtract 16, because in the original equation, there is no 16. So we need to cancel that out somehow. And we can also simplify this into x plus 4 squared. And if you think about it, if you redistribute this out, then you would get the same thing. And then we get minus 16 on one side. So that's just for the x values. Now let's move on to the y. So the y is going to be y squared minus 6y. And let's do the same thing. So then we take the b value, which is going to be negative 6. Remember to include the negative. So that's going to be negative 6 over 2. That's going to be negative 3. And negative 3 squared is equal to 9. So now let's rewrite this, bring it down. Y squared minus 6y plus 9 minus 9 at the end. Alright, and now let's factor this. What we can do is y minus 3 squared minus 9. So now we have two parts. Let's combine them. So we have x plus 4 squared minus 16 plus y minus 3 squared minus 9 is equal to 24. Next we have x plus 4 squared plus y minus 3 squared minus 25 is equal to 24. Then we have x plus 4 squared plus y minus 3 squared is equal to 49. And what we can solve from here, this is standard form right now. So this is all we needed to do. And in order to find the radius, we just take the square root, 49. Alright, so that's pretty much how you work with circle equations. And the next thing I'm going to cover is complex numbers. So complex numbers is I. So you might have seen this number before, and I represents the square root of negative 1. You can't really take the square root of a negative number, so this is why we give it this variable, this special I. So let's go through the exponent rules. So if we take the square of I, so we just I times I, that's going to be square root of negative 1 times negative 1. And that's going to be negative 1. So I squared is equal to negative 1. I cubed is going to be broken down into I squared times I. So I squared is negative 1. So then we get I cubed is equal to negative I. And lastly, what we have is I to the fourth. I to the second times I to the second. That's going to be negative 1 times negative 1, and that's going to be 1. So here are all the rules. I is equal to rad, negative 1. I squared is equal to negative 1. I cubed is equal to negative I. And I to the fourth is equal to 1. And anything after 4, you just repeat. So let's say I to the fifth, I to the fourth, times I. And then you get the gist. It's going to be rad negative 1. Alright, so this is going to be expression with complex numbers. So 3 plus 4i is equal to something else. I don't know. You can also add them together. So 4i plus 6i That'll just be 3 plus 10i. You could just add those terms together. Just think of it like a variable. However, in division, we do something different. So let's say I had this equation. So 3 plus 4i over 8 minus 2i. Now the problem is that we don't like to have complex numbers in the denominator. We could probably simplify this by using something called the conjugate. The conjugate is going to be the same value, but different signs. So we want to get rid of this denominator. So we're going to use the conjugate of the denominator. So let's just multiply it by that. 8 plus 2i. And see the sign change? This goes from negative to positive. Alright, so we do the same thing up top. And let's multiply it out. So 3 plus 4i, 8 plus 2i. So that's going to be 24, 38i. And now, note the properties of I. We have 8i squared. So I squared is equal to negative 1. 24 plus 38i minus 8. So then we have 16 plus 38i. So then we have 16 plus 38i as our top, or as our numerator. Then with the bottom, we do the same thing. So we have 8 minus 2i, 8 plus 2i. Since the different signs, the middle term cancels out. So we have 64, and we have minus 4i squared. So 64 plus 4 is equal to 68. And as a result, what we're going to be left with is 16 plus 38i over 68. Next, we can also simplify this by breaking it up. So 16 over 68 plus 38i over 68. And then we can divide this further. So it's going to be 4 over 17 plus 19i over 68. You can also see it written as this. Sometimes textbooks like to put the I in front of the fraction, but both are equivalent. Alright, that's all I have for today. I hope that this was helpful. If you have any questions, be sure to leave them in the comments below, and have a good day.